so here the question is saying that f and g are two twice differentiable functions on R, and we have to find the not correct option out of the four options given. Okay. So obviously this is the expression given. We'll try to integrate it both the sides. Okay. So when we'll integrate this both the sides, I'll get f dash x is equal to g dash x plus integral of 6 is going to be 6x square by 2, that is 3x square. Okay. And plus c1, an integral constant is going to come in there, right? And then we have the values of f dash 1 and g dash 1 given by this. So from this one, f dash 1 is what? F dash 1 is given to be 9 and g dash 1 is given to be 12 upon 4, that is 3, right? So if I plug the value 1 here in this expression, f dash 1, that is 9, is equal to g dash 1, that is 3, plus for x is equal to 1, this is going to be 3 plus c1, right? So from here, I am getting the value of c1 to be 3. Fine. That means this expression I can rewrite as f dash x is equal to g dash x plus 3x square plus 3, right? So now we have this expression here. Okay, let's find out the function fx dx and then we can try to filter out the options. Okay, so right, I have this expression, I have the constant c1. Now I can erase this one. Okay, now again I'll integrate this once more on both the sides. Okay, and then this will become fx is equal to gx plus the integral of cx square. This is going to be x cube plus 3x. Then again some constant c2, let's say. Okay, and then based on this information here, I can figure out the value of c2, right? f2 is 12. So if I take x is equal to 2, f2, that is 12, is equal to g2. g2 from here is 4, right? So 4, x is 2, right? So 8 plus 6 plus c2. So this is giving me c2 as minus 6, right? So that means I have the final expression, this one. So I can say fx is equal to gx plus x cube plus 3x minus 6. For c2, I'll write minus 6. Okay, now I can erase this one. I have the value of c2 now. Okay, we'll check that whether this is correct. First one is correct or not. So for that, I can say from this one, I can say gx minus fx is equal to 6 minus 3x minus x cube is equal to x. I have to put minus 2, right? So g minus 2 minus f of minus 2 is going to be 6. And for x minus 2, this is going to be plus 6 again. And then this is going to be plus 8, right? So this is going to be 14 plus 20, right? So I am getting the value 20. So this is true. Okay. We have to find out the ones that are not true. First statement is true. So that cannot be the option. Okay. Now let's look at the second one. So for second one, I have to write fx minus gx. Fx minus gx is equal to x cube plus 3x minus 6, right? And they're asking about the modulus of this. So mod of this is the mod of the right hand side element. Okay. You have to tell whether it is going to be less than 8 whenever x is in between minus 1 to 2. Okay. So that means you have to comment about the values of this particular function here, this particular expression in the interval minus 1 to 2. Okay. So let's try to figure out the values. Okay. Now this function here, if I draw, so this is the coordinate axis. Okay. This point here is minus 1 and here somewhere we have 2. Okay. Now we have to comment about the value of this function. So x cube plus 3x minus 6, if I differentiate it, we get 3x square plus 3. Now this is always positive, right? No matter what x is, this is always positive. That means this thing here, x cube plus 3x minus 6, is an increasing function, okay, for all x, okay. Throughout, this is an increasing function, right? That means at -1 here, we are going to get the minimum value for this, and at 2 we'll get the maximum. So for -1, let's see what is the value of the function, okay. If I plug -1 in this, I'm going to get -1, -3, -10 here, okay. So this is -10, and then this will be increasing. Well, the value of x changes from -1 to 2, right? At 0, the value is -6 here. It will be passing from this point here. And at 2, if I plug x is equal to 2 in this one, I'll get 8 plus 6 minus 6. So that is 8 here. Okay, so 8. So the graph has to be something like this, right? This is -10 here and 8 there. Okay. So now the question asking modulus of this thing. Okay. We are not being asked about x cube plus 3x minus 6, but the mod of this. So the mod of this will be, I'll take the mirror image of the part that is at -1, the value was -10 for this thing. If I take the modulus, the value is going to be 10, okay, on the positive side. It is going to be corresponding to this. It will be 10 here, right? So modulus of x cube plus 3x minus 6, the graph is this one here, right? This and this, right? Now, the question is saying that modulus of fx minus gx is less than 8 throughout for all the values of -1 to 2. That is not true, of course. We can see that this value here was -10. So, if you take the modulus, this value will be 8, 9, like that. So, all these values, they're all greater than 8. So, this is obviously not true. This will be the answer for our question, right? So, we just have to select one option out of the 4. We can select the second one, that is the not correct one, right? But still, we can see the other options also, if they are true or not. They have to be true, of course, right? So we'll check the other options as well. Now this f dash x minus g dash x, mod of that is less than 6 for the values, these values, okay. I have the expression. So from here I can say f dash x minus g dash x is 3x square plus 3, right? So this is obviously positive. So mod of this is the same thing. 3x square plus 3 is a positive thing, right? The modulus of f dash x minus g dash x is 3x square plus 3. If I make the graph, it is going to be something like this, right? In this interval, -1 to 1. This is -1, this is 1. So obviously, this is like this. 1 and -1, they are not included, okay? And this is 3. This point here is 3, okay? So is that always less than 6? Yes. Of course, right? For 1, the value is 6, right? So this value here is 6, right? This is 6 here. So this graph here is throughout below that line of 6, okay? There is no value on the graph, okay? Because the endpoints are not included, right? For it is written less than 1 and greater than 1. So for 1, the value is fixed, but we have to find the values in between. In between, the values are all lesser than 6. So this is again a true statement, okay? And let's see the fourth one. There exists some x naught between 1 to 3 by 2 such that fx is equal to gx, right? Fx is equal to gx, that means this thing again has to be 0. And we saw from the graph here, right? We saw from the graph of x cube plus 3x, fx minus gx is this thing here, right? X cube plus 3x. And the graph of x cube plus 3x minus 6 is this one, the black line here, okay? This one here is the graph of x cube plus 3x minus 6. Obviously, this is a continuous function, increasing only. This particular thing, the value of this particular thing at -1 was -10, and at 2 it is 8, and it is continuous. So obviously, it will intersect the x-axis at some point. That is the root point, okay? That is the root point here. And obviously, you can find out if you put 1 in this thing. So here we have 1, here we have 1. So for 1, the value of this thing is -2, right? And for 3 by 2, if you find out, for 3 by 2, the value of this particular thing is going to be, I will plug 3 by 2. So that is 27 upon 8 plus 9 upon 2 minus 6. This is a positive thing, right? This is, if I find out 8, 27 plus 36 minus 48. So this is 27 minus 12, right? That is 15. So this is 15 by 8 here, right? So this is 3 by 2 here. And for 3 by 2, we saw the value is coming out to be positive, 12 upon 8. So that is a positive thing, right? So between 1 and 3 by 2, we'll have a root. So fx minus gx will be 0 because this thing has a root. This is becoming 0 for some value of x in between 1 to 3 by 2, right? So option number 4 is also true. The only option that is not true is the second one. That is our answer for the question. Okay. So we have the answer option number 2 for the question. Okay. Thank you.